And you can see how the increase in the probability increases the odds also.
Got it.
Now, full
Okay.
disclosure, I don't know why one is preferred over another.
Okay.
But in like sporting events, they give you odds, or they give you
Yeah.
betting lines, money lines, which I mean are kind of different. They're related, but probabilities are more of a specific event. Odds, I suppose, tell you more about like how many successes you can
Yeah.
have of each. Kind of like
So
you
that's
would
maybe
expect.
why it's like preferred with binomial distributions, is because it's
Yeah.
like out of these two options, like
Yes.
3 times it's going to go this way and 1 time it's going to go that way out of 4.
That's a good way to describe it. Yes.
Yeah. Cool.
All right.
Okay.
Number 3. Got some sort of equation here.
Yeah.
What does it say?
And so with this one, I just plugged in the numbers given.
So
to
what I'm hearing though is there's no transformation of the variables, and that's
no.
what I'm looking for here. You're not actually taking like the logarithm of these. You're just using them as is.
Yeah,
So,
I think you're just plugging them in, and because like the default or like yes is going to be 1, then we plug in 1 for like we multiply 0.65 times 1, 0.0057 times the balance, and then the 0.003 times the income, and then just finding that number would give you the probability, correct?
Okay. Yes, and the only kind of like other piece of information I could say is like last test you had to build the equation.
Yeah.
And I think that you might have done that in the homework assignment we worked on. You may have to do that potentially, although
Okay.
not sure.
Yeah.
Yeah, I mean there's a binary variable, or I guess they called it nominal in your course. So yeah. So,
Okay.
I mean, as long as you're comfortable with that,
Yeah.
got it. yi equals 1. Do you need to? So what I'm seeing here also, there's some notation, kind of a like the instructor is telling you. Let me snip this in. There's sort of this notation of like you've got to sort of like identify the values before you put them in. But
So the test is all multiple choice, so
okay, so they
like
won't have to do that.
doesn't really matter, but I do have it written on my sheet, so like I'm gonna take the sheet in. So
That's another thing they could do, is they could give you the question where they ask you what the variables are. Like they just
yeah.
you have to figure them out and not switch them around. Okay. Let's go to the next one here.
Then yeah, for the 4th question, so I have like written down so on because the answer key just says like refer to the slide. So for what is the interpretation of the estimate of negative 0.65? So that's the number next to the yes, that's what's multiplied by 1. I have on average the all odds of default for the students is roughly half, because so e to the negative 0.65, approximate 0.52 of the odds of default for the non-students while holding the other variables fixed. I'm just like a little confused as to the interpretation of the estimate.
Yeah. So it's, I don't want to describe this here. So if this were a regression model that were linear, we would associate it with an increase in yes, or the fact that yes is some sort of a variable.
Yeah.
So it contributes to the probability of default, like you said, but I think it's like you said, it's the e to the minus 0.65 is the part that it contributes. And let's see. So this is a logistic regression model. Is that right? Because I see that in your other notes. See logistic.
Yeah.
Is that what you guys are doing?
Yes.
Let me do a, let me do a
So
quick search.
this test is like logistic and then ANCOVA stuff.
Okay. Oh wow, you're really going deep into the toolbox here. I just need to do a quick refresher on this.
Okay.
I mean, the traditional language is like something about the size and direction of the relationship based on the fact that it's negative versus positive. That'd be another words you might see. Since it's negative, e to the negative makes it go smaller versus a positive. But it's usually per unit change. Since S is a nominal variable, we probably need to look at that a little bit more. Nominal variables. So I mean, I see a resource here where they talk about the odds change, I think is what you mentioned.
Yeah.
And maybe that's what you already kind of looked at. Here is here's kind of something I found real quick, that it says that the odds ratio that associates, in this case, smoking to risk of heart disease, it means that this result here is the odds ratio of the group that is default versus not in default has.
Yes.
Okay.
Okay.
So
That actually makes sense.
Because
in like the logistic, right? Technically that piece, because it would be like B1 times X.
Yes.
And then so taking okay. That actually makes sense. Okay.
So I think you're looking for a keyword like odds ratio, especially since the instructor just said that in the previous problem. These things are very predictable. So if you see it in a previous problem, it probably means you're going to see it or leads to it in the next.
Yeah. Okay.
All right. Can we move on to 5 now?
Yes. So I don't really know. There is no actual 6 question. Like I got confused by that. But I think it's just understanding ROC curves with like the AUC. And so with this, an AOC closest to 1 is what you want. And so basically an AUC is like a measure of the area under the curve. Oh, that makes so much sense. And so you want it to be as close. So like A would be the correct answer for 5. Because it almost, if not does, fill the entire box.
Right. So the other way they ask this is the other direction, like somehow they ask which one is the worst or the least helpful, or they use some language, like it's probably like an A or a D situation. Now I mean, just pure calculus here, the area under the curve here is not 1 unless they're considering like 100 and 100 as the unit. Yeah. So there's some other, maybe they mean the ratio of, I don't know, the red to the green versus the whole triangle. Yeah.
Can the AUC dip below the green?
I mean, you kind of see that here. I mean, yes, I think it can, but that's where I'm not sure how they're calculating it. So let me just do a quick investigation on that. Give you more information if you want it.
Yeah, that'd be great.
So they kind of have this dividing. The reason that green line is there is they're saying that this way is good and this way is bad. So that answers your question, is that they can go. But in terms of how it's calculated,
I think it might be the entire like area, basically from like 100 to 100.
Okay.
I think is what I remember, but I also let me see.
Yeah, I think it's the whole area. It's a ratio of the whole area
Yeah.
to the whole box, or that like what's under the curve versus the whole box.
Yeah. I
They
think so
give
too, because
you
it's like looking at rates.
right, you're integrating rates, and so TP plus FN. Yeah. I can't find a picture where it just gives you the divisor in terms of the picture, but that's what I'm gonna say probably has to be.
Okay.
All right. So you said there's no 6, but there's an answer for 6. Is that?
Yeah, like it says A, but I'm just gonna like I don't know what happened there, I think.
Do you have an office hours to go to, or?
Yeah, I can
Okay,
go check in.
might be worth doing.
Yes. And then but 7. So this one to me just seems like very straightforward of you like technically could have all true positive error or no true positive error. So because
I
it's a
mean,
rate.
I see a lot of graphs here with true positive rate graphed along here, and then false
Yeah.
positive rate graphed along here,
So
and it could be anywhere from 0 to 1.
so that just seems like common sense. Unless like there is more to it, but I don't think
Let me
there.
see if the answers, did the answers provide any? Yeah, it just says from 0 to
Yeah,
1.
just 0 to
0
0
to
to
1.
1.
Yeah.
So that is pretty straightforward.
I mean, I suppose they could ask you a question where they say, which of the following is not a possible value of a true positive rate?
Mhm.
That's the kind of way that they ask these things.
Yeah.
But
Okay.
got
Yeah.
that in your notes. All right, number 8.
Yes. And this one I just like from notes, it's 1 minus the true positive error rate is equal to the false negative rate, which is the false negative over the true positive plus the false negative. And I think that's just something like I have to know.
That leads me to this thought that sometimes they can't really give you a practice test, because if they give you the practice problem, it's going to be the only type of problem they give you where you have to do that calculation you just said. Like where you have to use it to find something else. So there's one missing variable out of that group that you mentioned.
Yeah, I will say, like my last midterm, it was quite literally like these same questions, or the way he changed a question was he maybe like moved around an answer or like replaced one of the answers, but he didn't replace the correct answer. So the correct answer was still there. So like very easy stuff.
Right. Well, that it sounds like an instructor that wants you to go to his class and listen to him and remember the things he's telling you. And if you do that,
Yeah.
you'll get a good score. Does that seem consistent with his style? Is that kind of the
Yeah.
type of, okay. Now
Very
I'm reading in here in the solutions, page 49 of the logistic regression slides. What is on page 49 that might be different than anything you just said, or is that it?
yeah. So that's what's on page 49.
Okay. And
Which
did he give a numerical example of that? Did he say like if the true positive, if TPR, equals 0.4, what is the false positive rate?
let me actually take a look. I don't think so. But might as well double check. And this is still logistic lecture 49. Yeah, 1 minus true positive rate equals false. Oh, he did give a numerical example, which I think I'll just clip in to my notes really
Okay.
quick. But it's just like going off of the confusion matrix.
Okay.
That I think we did like a problem with my past homework.
Okay, and
Um,
if you haven't done it, I mean, try the numbers, make sure you know how every number is determined so that you're not surprised in the exam, how to do it.
yeah, okay,
All right,
amazing.
so this is, sorry, I don't need to, didn't need to submit that in.
Okay. Um,
This looks like it
Well-
came from a textbook.
Yeah, so this, he just like this, from class B1 is the slope of the first model. And then with like expected y, x is like little x, and then d is 0. B2 is the difference of intercepts. So it's taking like the slopes of e, y, x, d when it's 0, and then the same thing, but d when it's 1. And then B3 is the difference of slopes between those two, like betas.
So if you were doing this regression model, you have to add a column where you multiply x and d, and they're trying to find the interaction between them. Have you heard that before?
Like this is for ANCOVA. No, yes.
I would have to check, but I like when I see this, it's always an interaction effect between two variables.
Yeah, so typically we have like the d is like the dummy variable. So we did an example in class
Oh, I see. Yes.
where it was like about marketing.
Okay.
And there was like mailings, and so the two variables were like number of mailings or something like that, and then hours spent, and then the dummy variable was if they were aware of something before the like advertisement went out or something. And the
Yes.
dummy variable is a binomial variable,
Okay. Yeah.
so either 0 or 1.
Right. Yes. Okay. So the B0, B1, B2, B3, they're coefficients you find in the regression model, and
Yes.
those are indicated. X denotes years experience, 1, 0. But what? And you somewhere D is denoted, like in your notes or something. Like it's not here.
D is like the dummy variable, so
Okay.
it's like
And
binomial.
and you know that in advance. Like what I'm saying is that is not in here. So it like
Yeah,
if
no,
you did,
that's like something I know from class.
okay, yeah, and because it's not like X2, I can tell you that it's that, but I didn't know if you knew that.
Yeah.
And then like you said, it's now, we're considering another possibility when it is in play.
Yes.
Okay, so as long as you
Yeah.
have
So
that.
those like 9, 10, 11, I feel pretty comfortable with. Just we like worked a lot on that in class.
Did you do any data sets with this where you had to use the software and calculate these values, or read a table or anything like that?
So I have that all in a homework in our we had a ANCOVA homework.
Okay.
And so I have it all written down, and so I have like the parameter estimate box with like each estimate labeled, like the intercept estimate is B naught, and then like for this like hours of effort estimate was like our B1 line, and awareness estimate was B2, and then hours times awareness was like B3 with everything written down. So I think for like the test, I have all of that information available.
Got it. So okay, so let me just, you said something earlier, now it's kind of like I think this could be helpful, is the last test you had a study guide with the multiple choice answers in it, and this one does not. Is that correct?
True, yes.
So what I think, and you said the test was really close to that. So what I'm hearing is that maybe people did really well. So the teacher's like, hey, I'm not going to give you the answers this time, but if you know how to do these things, you will get the answers. So he's taking away the answers that you can't just replicate those, but if you know this information, you can get the answer.
Like I'm sure like interpretation of B1 multiple choice question or an answer will either be like, oh, it's the slope of the first model, or it'll be like the D expected like Y(x) when D is 0.
Yes.
For like having all that information, I
Right.
feel like it's all good.
Okay. All right. So we got a new question here. He's the way this is asked, it's like a true false, yes or no, or it's like in a multiple choice, it would be like, 2 yeses, 2 nos, and with the proper thing here. So what I'm looking at, and I think you probably saw this in the notes as well, is there's always an assumption like this is required to do the ANCOVA.
Yes.
Which leads me to ask you, like, do you have all the requirements of an ANCOVA in your notes? Is that, remember last time with, I don't remember.
Yeah, that's something I will note to clip in. Clip in requirements of ANCOVA. Yeah, I'm pretty sure that's on one of the lecture slides, so I'll go and
Okay, so like this, you could write an equation on. You can see, significance. The interaction is not significant, but everything else is. So maybe, you'd be asked about rejecting variables or not. All right. So question 13.
Yeah. So this question got cut out. It's supposed to say the above table contains a jump output after fitting an ANCOVA model to the data set. What is the distribution of the BIs? And basically, I think that's testing another, like it has to be normally distributed with model assumptions. So
last time we talked about that they're normally distributed, but they had, depending on the model, like when we were doing the least squares, it was like they each had their own variance. In the multiple linear regression model, they had different variances, but there's an assumption here of same variances with the ANCOVA.
Yeah. And so like with this will not be on the test at all, but just from my understanding, this is like pooled data because variances are assumed to be equal. So we can pool the data, right?
Yes.
Okay, cool. Yeah. Okay. So normally distributed. That makes sense.
So the notation for normally distributed with mean and variance is that, remember, if you go back to your previous exam notes, you'll see that there was some notation, mu and sigma squared, and you might have to double check that you understand that, or that it's clear.
Okay. Yeah.
Getting into that.
All
right.
Cool.
Number. All right.
14, so I'm kind of confused on.
So the 14 refers to whether you can reject or fail to reject something.
Yeah.
So when 0, if that's 0 and your confidence interval is to the right of it, you can typically reject. Or similarly, if your interval is to the left of it, you can also reject.
Yes.
But if
that I know, I just don't know how, because I think it's dealing with the table that was the like yellow.
Right. So where's beta 3? Here's beta 0, beta 1, beta 2, beta 3. What does your p-value tell you? Can you reject?
Oh, fail to.
It's too big, right? You
Yeah,
can't-
failed to reject the null.
to-
So, oh, wait.
So your null hypothesis is that they're equal to 0. Is that right?
Yeah.
Beta is equal to 0. So you can't reject that for this one. And the p-value
So
supports that.
wouldn't that mean that then for 14, do we think 0 will lie?
So the answer is
in the
yes. Sorry.
confidence?
I mean, it is yes, because you're going to, you
I'm
can't,
pretty sure the answer key said no, but
what?
I think that's why I was confused. But maybe the answer key didn't say no, and that was just like
It does say no. So that's a question maybe to go in there and ask, because, hey, I'm looking at the p-value here. But the thing is there's a p-value for the model that's different than the confidence interval. But they usually do provide a confidence interval on these. I would tell you that it does, since you're rejecting it.
That's what I think. I think that's why I was so confused, because I looked at it and I was like, what?
Yeah.
So okay, I'll go ask about that.
Yeah, I mean, you're the type of student that's going to go follow up on this and find out, because maybe there was some other intention that you now know that the other students won't.
Okay. Well, I will ask about that.
All right. Does 15 have 2 questions, or is it just
15, I think, is not the clips. It's just what will the t statistic use to test H, not B1 equal to 3.
I see. All right.
So I just have that from my notes being, we take like the X estimate basically. So the B1 estimate minus what B1 equals to test our hypothesis over B1 standard error. So it would be like 2.034 minus 3 over
so
0.1.
it's still always X minus mu over standard error, no matter where you are in the course. So this is mu. Their X is given right there. Then you can calculate that. You can do it for all of them, right? You could do, be asked for any of that. So
cool.
Okay, good. 16.
And 16, I'm a little bit confused about, because so I understand how the standard error is not going to change, or because it's still going to be the same distribution basically. But I don't understand how the sign, because the answer key says the sign of B2 is going to change, but we're not adding any negatives.
Yeah. I mean, I think, like you said, the first thing is, okay, we know that the standard error is not going to change, no change.
Yeah.
Okay. Like, I guess I was going to say, well, if you've never done this, this would be good to go in and, in the software and just switch the coding of the variables and see that the only thing that changed is the sign, and then the standard error is the same, but now why? I'm going to do a quick search for that, because I don't know. The only words I'm finding, they still don't really answer the question. Let me just see if I can. This is from Stack Exchange, but it just says when you change the coding, you change the reference level, and therefore you change the estimates, the sign of the estimates.
Okay.
Let's see if I can find another one. I think this idea of this reference level, it helps you to decide, well, if like when you say 0 to 1, like what does that mean? Like what does it being 1 add to the model? Whereas when you reverse code them, you're now going the other direction. So like, let's say we think that when you make it 1, it like the model says you get more of something. Well,
Okay.
when you reverse code it now, meaning like it's kind of going the other direction.
Yeah.
We now the model has to reflect that, meaning it would go down, because your baseline in the new model, the baseline is as if you have that like extra feature.
Okay.
And by when you code it to a 1, it's like it goes away to become, I'm thinking of like options in a car.
Yeah.
You know, like okay, we have the options, so the price of the car goes up.
Okay.
If you start with the price of the options being coded as 0, and then 1 means you don't have the options, well, the price of the car goes down. And that's why the sign change occurs
Okay.
in the coding of the dummy variables. It's all about that reference level being like lower or higher, depends on the scenario.
Got it. That makes sense.
Okay, no. All right, 17.
Yes.
17.
This one I also I'm like a little confused by.
Parallel equations for the two groups. Huh. I don't know what that means.
That I think I'll ask him about.
Yes. That's not useful.
Yeah.
Let me, is it okay if I spend 2 minutes here looking up something on this? Because I don't know much about it. Again, this is just straight out of the internet, but it suggests that parallel slopes models result of a multiple linear regression model that has both one numeric explanatory variable, which is what you have, and one categorical explanatory variable. That's your X, and that's the D. That's not,
Yeah.
but why? Does the model, is the yes because the p-values are significant for both X and D? That's kind of the direction I'm leaning on that.
Yeah.
That's why it is the case. So good question would be like, well, if the D p-value is like 0.4, which is something, would then you say, would the answer to this change? Would it be no longer parallel? And I think that's what I'm seeing here. They're not,
Okay.
it's not like they're actually parallel. It's that they are both included in the final
Okay.
model.
Okay. I'll ask about that and see like what we like need to know about that for the test, because well, whatever.
When is your exam?
Wednesday, so I'm gonna go to office hours tomorrow.
Okay. So you get some time.
Yeah.
All right. In a MLR, what is the minimum value of VIF? This sounds like a work question where you got to know the acronyms.
Yeah, so the VIF I think is just like the variance inflation factors, and so from notes, when it equals 1, there's just no correlation. And so you want your VIF to be, I think, like greater than 5 to show real correlation.
Yes, this is asking for the minimum value of VIF, and I believe it's 1,
Yeah.
but it can actually go up forever.
Yes.
And there's different like thresholds for whether like giving it meaning.
Yeah.
Variance inflation factor.
Yes. Well, that I understand.
Okay.
So that works.
They sometimes ask you to calculate it, but it doesn't sound like that will be part of this.
I don't think we've ever calculated that without like just using jump.
Yeah.
Or no, yes, we have. Wait. We totally have, but it's just like a simple equation. I believe.
Might be good to look up a numerical example in your notes, or when you go to office
Yeah.
hours, ask, how
Well,
to
that's
do
what number 19, I think, does.
Yeah, so the formula here is VIF is 1 minus 1, or 1 over 1 minus RI squared is one of them. I mean, there's a few other ways to write it, but you have a new problem here. Yeah, the 2 covariates. If only, okay, let me snip it in.
Is 0.7. So then it's just like the same covariate with the same equation. So it's going to be the same.
Yeah, there's a VIF for each correlation. Only two covariates. Correlation 0.7, V1 will be the VIF V2. Be the same. Okay. So does he actually do the calculation in the? He does. So this is the RI, and then he says that they will be the same. How could this question be asked differently? I just remember there's like a table. Sometimes they have you present that they have the variables, and like down the diagonal is 1, and then you have to figure out, like D, like they'll have numbers filled in for them, but they only use one triangle. But you're saying I mean, this is a very nominal calculation, 1 over 1 minus 0.7. That's not a real big deal.
Yeah.
But you can do it for any combination of variables potentially. Do you have any other notes on that? Any other example?
The one thing, so let me try to see here. I think I'll ask about this too, just like what we're going to be tested on exactly. I have notes from, so there's like an example where the VIFs are all pretty high, but the interaction term is insignificant. And so it says, it should not surprise us that the interaction term has such a high VIF. This is because of the obvious reason that the interaction term is collinear with the variable D and the variable X. The fact that the interaction term is insignificant tells us that the two regression lines are parallel, and what we see is indeed due to chance variation. So we can drop the interaction term and rebuild the model.
Sounds good.
But
yeah, just a few other things I'm seeing here. Like you said, you got to look at the values of it, and then there are other calculations for it. So just be careful. Which ones they're asking for. Like it seems like he's just emphasizing this one, but maybe there's another that you might see. They also can sometimes show you graphs of the relationships of the variables. The software probably has that in there as well. Let me just quickly show you that, they variables start lining up. They try to
Yes.
give them to you together, things like that. Right. The last question on this problem set.
Yes. So this, so in a multiple linear regression, the null hypothesis corresponding to the p-value in an ANCOVA table would be, so h naught is r squared equals 0 versus HA is r squared not equal to 0. And so what that basically means is that h naught is B1 is equal to B2 is equal to B3, B whatever, which is equal to 0.
Mhm.
So each of those will be 0. And then our alternative is not that they all aren't equal to 0, but at least one of them isn't equal to 0. So all, like, if you had 6 BIs or whatever, just one of them would have to not equal to 0 for the alternative to be true.
That's right. Now, everything you said was great. I want to point something out here. When a teacher does this, instructor, whoever, they're going to ask you something about this. Like I see a situation where they tell you H0 and they include B0 in one of them.
Oh, wait, yeah, that's
It's a very small thing, but this is the kind of thing I think there's a reason that when a teacher says this is so important, you got to remember this. They're telling you, I'm going to test you on it.
Yeah.
Maybe make a special note of that there. All right, so it sounds like you got a couple of things to talk to your instructor about on office hours.
Yeah.
All right, is there anything else I could quickly answer for you? Got a couple minutes left here, today's lesson.
I think that's really it.
All
Yeah.
right, let me go ahead and just stop the recording real quick and